want to find the 6 trigonometric functions for theta when p is at the coordinate 3, 7. So I need to sketch a coordinate plane, and I want to plot p in my coordinate plane. So when I do that and I draw my angle through p, the terminal side of theta means that theta is going to be the distance between the x-axis and the terminal side of the angle. I can create a right triangle, and I know that the bottom of the right triangle is 3, the height is 7. What I don't know is the hypotenuse. I'm going to use Pythagorean theorem to find the hypotenuse of my right triangle. So 9 plus 49 equals x squared, 58 equals x squared, and then here I want to square root both sides. Notice that it says the exact value. That means we have to leave it in radical form. We can't simplify this to a decimal and round. We have to leave it exact. We always want to check, does this radical break down? When I check, it doesn't. There's no perfect squares that I can take out, so I'm just going to leave this as the square root of 58. And now that I have the hypotenuse, I can find sine, cosine, and tangent of my theta. So remember that sine is opposite over hypotenuse. So sine of theta is going to be 7 over the square root of 58. The only problem is I'm not allowed to leave a radical in the denominator, so I have to rationalize my answer. So I'm going to multiply top and bottom by the square root of 58. So the numerator becomes 7 square root of 58 divided by the square root of 58 times the square root of 58. The radicals cancel, and we're just left with 58 in the denominator. My last step, I want to check, does 7 over 58, does that simplify? The answer is no, so I can leave my final answer, sine theta, is 7 square root of 58 over 58. Now I need to do the same thing for cosine. Cosine theta is adjacent over hypotenuse, and then rationalize, which is going to give me 3 square root of 58 over 58. It does not simplify, so that's going to be my final answer for cosine theta. Tangent is opposite over adjacent, 7 over 3. Here I don't have any radicals. I don't have to worry about rationalizing anything. Now for the reciprocal functions, I'm going to flip each of my fractions. So cosecant theta goes with sine. Notice that I had 7 over the square root of 58. Now I'm going to flip it to be the square root of 58 over 7. And you can also recall that cosecant is hypotenuse over opposite. So square root of 58 over 7. Same thing with secant. Secant is hypotenuse over adjacent. Or if I'm flipping my fraction, it now becomes the square root of 58 over 3. Last one, cotangent of theta is adjacent over opposite, so 3 over 7. Those are my